주에 3시간 하고 다다음 주 월요일은 진도를 나갈 수가 없죠. 그래서 이제 다음 주 월요일 아마 다다음 주 월요일에 제가 문제 풀이하러 올 것 같은데 문제 풀이하면 끝입니다. 얼마 안 남았어요. 오늘 월요일 수업 다 끝나면 이제 4시간 남습니다. 4시간 남고 얼마 없다고 생각하지 않을 수도 있지만 4시간 남습니다. 참고로 공지사항 따로 올릴 건 아니지만 기말고사 숙제가 아마 오늘 수업 끝나고 나갈 거고요. 구단은 숙제가. 그리고 기말고사는 그때 옵니다. 17일 날 10시부터 12시까지 옵니다. 그래서 아마 저번처럼 2개로 스플릿해서 봐야 될 것 같아요. 그렇게 안 하면, 그렇게 해도 제가 그때 못 와봤어가지고 후기를 못 들었으나 여기 비공사공은 엄청 제출하고 받고 정리하는 게 빡셌다고 들어가지고 조금 더 늘려서 나누고 싶은데 그거는 강의실 상황이 여의치가 않아서 잘 모르겠습니다. 그리고 수업하기 전에 그냥 간단하게 한 1분만 얘기를 더 하면 한국어로 어차피 한국어밖에 없어서 혹시나 이제 여러분들이 시간이 되시면 매우 어려운 것도 알지만 교수님들한테 혹시나 메일을 보내셔서 면담을 신청하는 걸 저는 강력하게 추천드립니다. 이유는 사실 저도 대학교 다닐 때 학부 때 교수님한테 면담 신청한 적이 3번밖에 없거든요. 2번 전체 다 해서 6년 2번 3번밖에 없는데 저는 되게 아깝다고 생각했어요. 나중에 이제 교수 되고 나서 교수 되고 나니까 약간 교수님한테 면담해야 되는 다른 이유, 여러 가지 이유들 중에 사실 가장 중요한 이유 중에 하나가 요새 정신 없잖아요. 여러분들도 도대체 레거시라고 하는 지금 저희들이 갖고 있는 수업하고 시대 변화가 전혀 매치가 안 되니까 여러분들도 혼란이 많을 텐데 교수님들한테 들어오는 정보가 되게 많아요. 여러분들한테 수업 시간에 그걸 다 풀어서 수업을 할지 못하는 거지. 당장 저만 해도 당장 데이터 센터 얘기부터 시작해서 HBM이라던가 이런 얘기들도 저한테 들어오기도 하고 그런 얘기들이 많이 들어오는데 그런 얘기들을 이렇게 얘기할 기회가 없습니다. 교수님들은 얘기할 기회가 별로 없어요. 수업을 그걸 위해서 따로 열 수도 없는 거고. 그래서 혹시나 관련해서 궁금하신 거나 이런 거 있으면 저한테 연락하라는 게 아니고요. 다른 저 포함해서 여러 기계공학과 교수님들한테 앞으로 어떻게 될 것 같냐라는 질문을 들고 가시면 되게 많은 얘기들을 들으실 수 있을 거라는 차원에서 여기 오신 분들은 얘기를 하면 한 번쯤 신청하시지 않을까 싶어서 그냥 높아시게 말씀드립니다. 수업을 시작하면 저희 녹화해야 돼서 So the last time we were talking about the auto cycle. Before that, I already said that. So we separate or divide the two kinds of the breathing cycle, not breathing cycle. So air-based cycle. The first thing is that internal combustion engine. Internal combustion engine includes the two kinds of things. The first thing is that auto cycle. Auto cycle is also called as a gasoline cycle. And the second thing is a diesel cycle. And the kinds of things is based on that, so based on the compression and expansion work of the reciprocating motion and the change into the rotational motion. So, which means that it is possible to make some compression and expansion work change into the rotational work, because before that, so it is impossible. And also the second thing is that in the very, very old fashion book, before that 1960s or 70s, at that time, so this gas turbine engine is also called as an external combustion engine. So the meaning is simple. So internal combustion engine is without, we assume that there is no additional mass transport happen with some ambient and in the cylinder, and then we can assume that control mass, so which means that so it is possible to calculate. We ignore the flow work term in order to calculate about the internal combustion engine. However, in case of the gas turbine engine, so air comes into this turbine and then goes to the compressor, combustor, and finally goes to the turbine, and then finally that directly goes into the ambient condition. So which means that in case of this system, so we should consider that flow work. Flow work means that so we should consider that the enthalpy in order to calculate the right side of gas turbine engine. So for this reason, so external combustion engine is also means that there's a gas turbine engine. So the last time I talked about the Otto cycle. So in the Otto cycle, there are two kinds of the characteristics that exist. The first thing is that in case of the expansion or compression work, the isotopic process is preliminary assumption for solving this problem. The second thing is that when any combustion happens or the exhaust happens, so the final stage we make case of heat exhaust happen at the bottom cycle, and at that time, so we assume that so constant volume happening in the Otto cycle. So for this reason, so we do not consider that the additional flow work term in order to calculate this Otto cycle, and also in order to analyze this energy analysis, we can utilize the closed system terms for the first law of the thermodynamics. And then maybe, I'm not sure that, but in case of the diesel cycle, this term is a little shifted related to the terms, because due to the very instant combustion happen in the system, so these terms also can be calculated by this internal specific internal energy. The reason why I explain about this fact again, because during the combustion, when you calculate about the finite time in order to change the combustion procedures, then the volume change, we cannot ignore that the volume change during the process. But in case of the Otto cycle, the temperature change due to the spark ignition, so which make some very instant temperature change during the process. So which means that before the changing the volume, the characteristic time of the changing volume is much larger than the combustion process. So in that case, we can assume that okay, so there is no volume change happen. So every kind of the energy just goes into the combustion. The changing the temperature, and then which goes to that. Then we can calculate. Okay, so we can utilize the specific internal energy for solving this Otto cycle problems. So, in case of the cycle analysis, so we finally guess that in order to calculate this thermal efficiency before solving the problem, so if we can assume the two kinds of things. The first thing is that if we assume that the specific heat is constant above the temperature range up to the 2000 Kelvin, and then the second thing is that isentropic process happen during the process, then we can change that every kind of the thermal efficiency terms before this page. Then we can change that, okay, so that terms change into the temperature ratio, and that temperature ratio also change it into the compression ratio. Which means that before the designing this Otto cycle, then we assume that okay, so every kind of system is determined from the geometrical factor, such as R. So if we can increase the infinity number of this compression ratio, then we can finally achieve that almost reach it to the unity value of the thermal efficiency. And also, I also explained about the two things. The first thing is that this is the preliminary analysis related to the calculating the thermal efficiency of this system. The second thing is that if we reflect the changing the specific heat with temperature, then we should utilize either gas table, which reflect the change of the specific heat with temperature. So then we go to the diesel cycle. In the diesel cycle, there are two things. Maybe here is the two line are the same as the Otto cycle, which means that so during the compression or expansion, I mean, this is the compression, this is the expansion. In that case, isentropic compression and isentropic expansion happen during the for making the work out or work in value. So this is the same procedure of this diesel cycle, and also this process is also same as a heat rejection is needed in order to operate this power cycle. Maybe here is a Q out. There is a W out, W in. And the difference between that Otto cycle and diesel cycle is this condition is later shifted. So in case of the Otto cycle, the process from the 2 to the 3 is volume change does not happen. But in case of the diesel cycle, the condition is changed into the pressure is constant during that process. In order to understand that the reason why we assume that okay, so not to utilize that this V is equal to the C, that V is constant, and why we utilize the P is constant. So then we need to check that the combustion process in order to for the preliminary design of this diesel cycle. So in case of the combustion, the way is the two ways. The first thing is that we try to utilize the external temperature like a spark. Utilizing the external temperature increased, then when we make some higher value, we try to make some ignition at a certain point, and then the ignition propagated to the inside of the whole of the system. So this is the one way to make some combustion process by utilizing this simple fuel and this air mixture. The second thing is that T2 over T1 is proportional to the pressure. We already know that, so this equation, so which means that when you increase the pressure ratio, then that also above the ignition temperature. So this kinds of the utilization of this concept is main combustion process of the diesel cycle. So which means that compared to this spark ignition, the time latency of this combustion, the combustion latency of that Otto cycle much smaller than the diesel cycle, which means that I assume that okay, so during the combustion time is too short, so we do not reflect the variation of this Otto cycle volume change during the Otto cycle volume change in the middle of the Otto cycle procedure for solving the problem. But in case of diesel cycle, combustion process is much slower than this cycle, so which means that during the process of this combustion, there is a volume change also happen. So, which means that we should consider that this volume change simultaneously in order to calculate this process. Then, when you assume the P is constant, P is constant meaning is that this system, before the understanding of this internal combustion engine, so for understanding of this internal combustion engine, so there is no mass transfer happen. I mean, during the process, there is no mass change happen in case of an internal combustion engine. So which means that this is the satisfying the Boyle's law. So Boyle and Charles law. So which means that T over the PV is constant. So if T continuously increases, then this PV relation is also changing, but during the process expansion also happens, so which means that we should consider that the three kinds of things simultaneously in order to calculate these equations. So this equation is a little shifted in order to calculate this behavior. Actually, so in order to analyze these terms, because the reason why these terms is existing here because this PV is also one of the work for solving the problem. The point is that actually, so in case of the closed system, we cannot utilize this term directly because this term goes into the flow work. But actually, in the classical thermodynamics class, the terms does not explain in the textbook in detail. So, as I think that so in the textbook, so this is for the better understanding of this term for understanding the design cycle, as I think. So, in case of the process 1 to the 2, this is the Win value. Maybe the derivation of the Win value are the same between the Otto cycle and diesel cycle. So this W terms is the change in the U2 minus U1 value. And also during the process, we already know that from 1 to the 2, the isentropy process happened. So which means that adiabatic condition also satisfied. So we can only consider that so this W12 over M is equal to the U2 minus U1 value. And then here, process 2 to the 3, so we should consider that this term. So I separated this P del V is this W is by utilizing the work. I mean, we add up some additional work or compression behavior or expansion behavior. Then this is like this intentional work. So there is an intended work. This is the similar meaning of that intended work. This is the P del V also the work. This is due to that. So due to the temperature change, this is the usually undesigned work, as I think. Undesigned work or wanted work. So during the 2 to the 3 process, we do not add up the additional intended work to operate this system. So which means that we can delete this term in order to get this information. So which means that Q to 3 over the M, change it into the 2 terms. The first thing is that due to that the combustion process happened, so temperature change also happened. So which means that which change into the temperature change at first in terms of the specific internal energy. The second thing is that there is also volume change happen. So this is due to that the combustion. So which means that due to that the combustion work, we can calculate that these terms in order to consider that. So this Q in value containing the additional volume change happen for solving this problem. Then basic definition of this enthalpy value is U plus PV. This term is the basic definition of this enthalpy value. So which means that these terms change into the enthalpy, and these terms change into the H2 value. So for this reason, different from the Otto cycle, in case of this diesel cycle, we utilize this H3 minus H2 value for expressing this Q in value in the diesel cycle. And then the remaining things are the same. So closed system, so work happen, or we need to it just happen. There is no additional flow work happen during the process, which means that in case of the process 3 to the 4, process 4 to the 1 is just utilizing the specific internal energy for solving the problem. So this summary efficiency is, so the reason why we separated this flow work term in during the combustion and this W, because I already said that this W is an intended work, so which means that so during the combustion, this process, this kind of the additional volume change process is unexpected. So which means that during the process, this cycle analysis is based on that only utilizing the specific internal energy change, which means that this W cycle meaning is that U3 minus U4, this is work output, and this terms is U2 minus U1. Which means that during the for the calculation of this diesel cycle work, the cycle work is just considering that the work output value with the work input value intentionally. We do not consider that the additional some unwanted, the unexpected work for calculation of this process. And then this Q value also containing the information about this H value. So this work term goes into this Q value. This is H3 minus H2 value. So which means that we only consider that the Q value, and this Q value induces the pressure change, the volume change during the process, but this combustion expansion or work is also contain the information of the Q in value during this diesel cycle. So which means that we only consider that these enthalpy terms in the here, and then we change that when you consider that this W cycle value, and then we only consider that the specific internal energy terms for calculating the summary efficiency. 한국어로 잠깐 얘기하면 원래 클로즈 시스템에는 저 위에 P 델타 V가 안 들어가죠. 원래 클로즈 시스템의 경우에 저희가 컨트롤 매스를 잡아놨으니까. 근데 제가 맨 처음에 아마 엔탈피 설명할 때 저 W 텀이 두 개로 바뀔 수 있다라고 얘기해 드린 적이 있고, 하나는 이제 플로우 워크 텀이라고 하는, 그러니까 실제 워크 사이클에는 반영이 안 되는 텀이 하나가 있고, 또 하나는 저희가 메카니컬하게 혹은 이게 의도를 가지고서 메카니컬 인풋이나 아웃풋 워크를 가지고 올 수 있게 되는 W 텀 두 개로 나뉜다라고 설명을 드린 바가 있습니다. 4단원 할 때. 그래서 이제 그걸 가지고 쭉 유도를 하면 저 엔탈피라는 개념이 원래 있던 개념은 아니고, 원래 클로즈 시스템에서 저 플로우 워크 텀 혹은 저희가 의도하지 않았던 텀들이 들어가게 되는 것들을 합친 게 엔탈피라고 말씀을 드린 바가 있어요. 그리고 그렇게 돼야 사실 사이클 에너지 밸런스상 텀들을 정리할 수 있어서 그렇게 얘기를 드렸고, 근데 이 디젤 사이클 같은 경우에는 나머지 3개 프로세스, 그러니까 1, 2, 3, 4, 4, 1 사이클 같은 경우에는 그냥 이제 오토 사이클하고 차이가 없습니다. 뭐 인터널 컨버션 엔진에서 뭐 차이가 날 게 없죠. 근데 이제 저기 H2, 그러니까 2에서 3로 가는 경우에는 아까 얘기 드렸지만 저 타임 베리에이션이 좀 있어요. 그러니까 되게 느립니다. 느려서 진동도 쉽게 실제로 이제 저희들이 디젤차 뭐 가솔린차 얘기하는데 디젤차를 사실 잘 안 쓰는 이유 중에 하나가 컨버션 프로세스도 느리고 컨버션 프로세스가 느린 만큼 뭐 안에서 여러 가지 현상들이 저희 모르는 현상들이 굉장히 많이 발생하고 그 중에서 가장 중요한 거는 결국에는 저희가 불 딱 붙였을 때 볼륨 체인지 없이 계산하면 딱 좋은데 그게 불가능해요. 손실이 납니다. 저게 결국엔 손실텀이라고 보시면 돼요. 볼륨 체인지가 Q인이 100%다 온도로 바뀌어야 되는데 온도로 안 바뀌고 볼륨으로 일부 간다라고 보시면 됩니다. 그래서 저거는 그 2에서 3로 가는 거는 일이 추가됐다는 개념보다는 에너지가 더 투입됐다라고 보시는 게 맞고요. 그러다 보니까 이제 서머 에피션시나 이런 거 계산할 때 이게 아마 나중에 숙제 문제였나 어디 나오는데 저 양을 구하라고 나오는 문제도 있긴 한데 있었던 걸로 기억하는데 그때 이게 막 계산하다 보면 저 서머 에피션시랑 저 텀만 계산하는 거랑 헷갈릴 수가 있습니다. 서머 에피션시는 그냥 저희가 W 사이클을 구하는 거로 충분한 거고요. 저 밑에 있는 저희가 의도했던 W 아웃 부분하고 W 인 부분만 계산하면 되는 거고 저 익스펜션 할 때 손실이 얼마나 되냐 뭐 이런 식으로 문제가 나왔던 것 같은데 제가 기억할 때 숙제가 그게 요텀입니다. 요텀을 계산하라는 얘기라서 뭐 그렇게 이해하시면 좋을 것 같습니다. 이게 생각보다 헷갈려가지고 오토 사이클하고 디젤 사이클 풀 때. Okay, then similar to that of the auto cycle, I mean the gas cycle. So this cycle is the basic term of these terms are the same. So the first thing is a compression ratio. Compression ratio is also the one of the dominant factor in order to determine the so in order to utilize this equation, we assume that the first thing is that cold air standard analysis. The second thing is that isentropy process. If there is no description about that, the two kinds of things simultaneously on the problem, then we can utilize the air standard analysis for solving the problem. Anyway, so this diesel cycle also changed into the equations, such as the first term is that compression ratio. This is the same, so this is the ratio of that the top dead center and the bottom dead center. I mean the VTDC or the VDC. Sorry, different. PDC, TDC. Sorry. Compression. Sorry. TDC. Yeah, BDC is the compression ratio. What sound? This is right. BDC or the TDC. So I confused the pressure ratio of this process. This problem. So then we can change this equation changing into this ratio, and also we can utilize these terms. But here there is another term related to the RC value, which is different from this auto cycle. So this meaning is that this is the ratio of that. This V2 is the top dead center volume. I mean, at the top dead center, and then there is the smallest volume of that in the system. This value meaning is that during the process, I always said to that these terms, there is a three kinds of thing, such as if the either case is here, directly goes to the V1 value during that process, this is auto cycle. But this meaning is that, okay, so during the process, that amount of the volume change also happens. So this volume change ratio is called as a cutoff ratio. So then we try to, okay, so we try to check that how to solve this equation, how to derivate this equation at first. Okay, so we know that T2 over T1 is, we'll work with 2, K minus 1 is R K minus 1. Then we try to get some information about to the V3 over the V4. The RC value is just variation of the V3 over the V2. And then this is the V3. We can utilize the chain rule, similar to that of the chain rule. We can change that equation is here. This value is cutoff ratio. V2 over the V1 also changed into that V2 over the V1 because V1 is equal to the V4. So then this is a change into that the 1 over R. So which means that so V3 over the V4 is the same as the RC over the R. So in case of the Collier standard analysis, we need information of the temperature ratio. T4 over the T3 is V3 over the V4. K minus 1 is equal to the RC over the R, K minus 1. And then T4 over T1 is T4 over T3. T3 over T2 is T2. And similarly, T2 over the T1, which means that RC K minus 1 over R K minus 1, RC R K minus 1 is equal to the RCK. The reason why I explain about these terms, so the thermal efficiency of this equation is 1 minus H3 minus H2 U4 minus U1, which means that 1 minus CV T4 minus T1 CP T3 minus T2. Then maybe this term is easy. So when you assume that the K is CP over the CV, then the terms goes to the 1 minus 1 over K. And this terms is a little complicated. So when grab these terms into the T1 over the T2 is T4 over the T1 minus 1. These terms, T3 over the T2 minus 1. Then we already get the several informations in here. The first thing is that we already get information about the T4 over the T1 is coming from the here. T1 over the T2 is here. And then T3 over the T2 is P2 is equal to the P3, which means that T3 over the T2 are the same as the V3 over the V2 to the ideal gas law. So, which means that this is a cutoff ratio, which means that this is also cutoff ratio. So finally, we can get the information now. Rk minus 1 over k, Rck minus 1, Rc minus 1. So equation is quite complicated compared to the previous Otto cycle due to the cutoff ratio. However, maybe the basic equations are the same. The first thing is that we need to check that the ratio relationship between that the volume ratio with the temperature ratio. And the second thing is that there are several kinds of concepts such as the cutoff ratio of the compression ratio or the main message during the process of this diesel cycle and Otto cycle. And the third thing is that even though that we utilize the enthalpy value to calculate this summary efficiency in case of the Collier standard analysis, but that all kinds of the terms is just determined from in order to determine the summary efficiency of this diesel cycle, all kinds of terms also changed into the geometrical factor with this property of the combustion air or air for solving this summary efficiency problem at the preliminary design of this diesel cycle. So this equation, so for this reason, this equation is derived from that the little complicated procedure to calculate these terms. So in graph, there is a very confused graph, but because usually nowadays diesel cycle always higher summary efficiency compared to the Otto cycle gasoline engine in the practical side. But in the ideal solution of this cycle is when we assume that so this cutoff ratio is the 1, there is no volume change happen. That the maximum summary efficiency is the best case during this diesel cycle. This is called as the Otto cycle. And then when you increase this cutoff ratio of C2, RC3 and continuously, due to that terms, the summary efficiency continuously decreased. But I always answer that in the real situation, so this Otto cycle summary efficiency is lower than the diesel cycle. So we should know that why these kinds of discrepancy happen. I always answer that we need to utilize this Otto cycle. We need some spark ignition, and the time latency combustion is much lower than the volume change. So the starting of the volume change time latency also exists in the problem. So which means that this meaning is that so V3 final volume usually determined from the initial pressure and initial temperature. Usually when the spark ignition happen, and then the volume temperature is a potential of this process, and then they finally finalize the value of that volume, end of the volume during the process. But in order to for the instant combustion, then this P2 T2 value is limited due to that the size of this volume, or because if we make it a larger volume for making the larger compression ratio, or a large compression ratio, then we would like to make it a larger volume, the top dead center volume. Then when we only add up the very small size of the spark and then propagation happen, that propagation speed is limited due to that the speed of sound. So which means that it is impossible to increase the compression ratio as much as possible. I mean, in case of the Otto cycle, compression ratio is limited at a certain value. But in case of the diesel cycle, we utilize a higher compression, increasing the higher temperature, and then during that the very long time, our only one goal is that, okay, so during the process we make the combustion process happen, and then entire combustion happen with efficient, the enough time, combustion time during the process. So, which means that ideally, diesel cycle compression ratio is much larger, not much, but larger than the Otto cycle. So in the practical side, due to that reason, at the same final volume of this system, diesel cycle the efficiency is larger than the Otto cycle. And this is also making the large work output from that system, because the compression ratio is also related to the work output. So this work output value is larger than this Otto cycle. So for this reason, diesel cycle is continuously utilizing the ship or tank or the very large vehicle are dominated by the diesel cycle. So in case of the very small car, the small vehicle, is dominated by the Otto cycle. Nowadays, many kinds of things are changing into the Otto cycle and diesel cycle now. Electric vehicle based on that the motor plus battery. But as I think that so at least for 20 or 30 years, between the 40 or 30 years, it is impossible to substitute the whole of this diesel cycle car changing into the EV car, as I think. So there are lots of reasons additionally, but after the 10-minute break, and I continuously explain about that problems or practice cycle.